thanks for coming. Today we're going to talk about a very hot topic. The boss of NVIDIA a few months ago said that the next stage for AI would be like real-life AI, robotics AI, and this is one of the main topics. You've heard about word models around like 225 times since this morning, so that's what we're going to talk about. Thanks you for coming. Firas, Grégoire, can you present a bit yourself so we know who you are?
Yeah, hello everybody. So I'm Firas Faraj, I'm CTO of AI manipulation at Enchanted Tools. I've been with Enchanted for the past two and a half years, and I come more from a research background in robotics.
Hello everyone, I'm Grégoire Lénard. I'm also CTO at Enchanted Tools. I'm in charge of navigation and mechatronics of the robot, and I've been there for 2 years as well.
So how does it work to have two CTOs in the same company? Like, is that not the first question that everyone asks you?
Yes, actually we have 3.
What? Why is the third one not here then today?
You have to ask him. He's just there. Yes, there are so many specific expertise in a robot that it's actually I think a really good idea to split features by people, and we have very different backgrounds. We join on certain expertise, but I'm really more on the hardware part, Firas more in the AI, and the third one is more about user experiences. So we can design the best robot possible with everyone, and the leadership is a little bit more difficult, but we manage.
And actually, it's not a rare setup in robotics startups in particular. So you find it in other robotics startups also. Sometimes like CTOs of industrialization and CTO of research, but a lot of robotic startups, they have co-CTOs right now.
Yes, but maybe most people don't know about that. So are you building the best robots? You said you were going to build the best robots. When can we buy this best robot?
Yes, we are building the best robot.
Good.
It's a little bit different than the other. You saw it this morning, opening the ceremony, Miroki and Miroka. They are quite different from other robots. It's still a humanoid robots because they look like a human, a little bit like animals as well. But they are made for social activities and living among humans. So it's already available in early access. We are selling the robots to research centers, to integrators, to learn a lot about how to use the robot and gather data. And we are still evolving the robot up to later next year to have a full-scale production. So
why is AI a game changer for robotics, right? Because we've been talking about robots since the 50s, right? And it seems that now everyone is actually moving, right? And we see new announcements about robots not every week like LLMs, but every month. So why is AI a game changer?
So it started a bit with deep learning, and first we had perception and AlexNet and so on, and it showed that perception is possible. So perception suddenly became possible, and then reinforcement learning in 2016, 2017 showed that actually, robots can be robust. So we had quadrupeds which started to walk in a robust way. We saw the DARPA challenge between 2018 and 2022. It was for mines. And we had quadrupeds deployed with reinforcement learning for the first time ever. There were still no products doing that. And so reinforcement learning make it possible for robots to be robust in environments. We started the company in 2021. The ChatGPT moment hadn't happened yet. And then the gods of AI gave us ChatGPT and basically LLMs and VLMs and now word models as a gift, which even scaled the acceleration much faster. So it has reinforcement learning first, then generative AI, and it exploded from there.
And using AI, what is different when you do robotics for AI? What are the specifics for running them? How do you use them? Right? Do you use the same models and do you deploy in the same way? What are the specifics?
I can start and then maybe you can take over on that. It is quite different because an error in a mistake in a robotic AI, it's not a typo. It's an avalanche, if you want, because the robot is always in a long horizon task. It's solving a task which goes for not just multiple seconds, but multiple hours at a time. And errors compound over time. So a very small error at the beginning leads to a bigger error, like slight different errors of 1%, 0.1% even. If you compound them over time, in 15 minutes, you failed your task. And if you fail your task every 15 minutes, no one will buy your robot. So basically, it is really very different. You need really a different level of success rate when you are working with robotics than when you are working with classic AI. But that's why it's also exciting. And that's why, until today, it hasn't been the moment of robotics yet. And it is becoming the moment of robotics now. Because right now, we are able to have models which are able to do very complex tasks with very robust performances. Even though they are still not the end-to-end models, one model does everything. So robots deployed are slightly different today, and the models are slightly different. We can talk about it if you want. But it's becoming feasible.
Yes, and if I may add, so robots are the embodiment of AI. They are physicals and they are in the real world. So we are running most of the models locally, and most of the people are using cloud in AI. So if you want to picture it, you can think about a lemon pie with a lot of cream. Everybody is focusing on the cream. They want the big part of the cream, and this is cloud AI. And we are doing most of our work on the crust. So it's very thin at the moment. A few people are working on physical AI and local AI. It's quite similar, but still a bit different because we have a low budget for everything, a low budget of resources, low budget of volume. So we need to run models that are more efficient, and we need a model to take so many different inputs that cloud, like the standard AI in the cloud, are not taking right now. Mostly it's text, images, audio, but when you are in a robot, you get sensors from touch, from everything in the environment. There are so many stimuli that you have to incorporate into the model to really have a good performance robot.
So that means that you need different type of models which understand more senses than just classical LLMs, but at the same time you need them to be small, right? So you have like both of the issue of how do you deploy it, and you need specific models, right? So does not that require a ton of resources and money to be able to do that?
Yes, at the moment, most of the robotic companies are doing a hybrid approach. So we are using cloud like ChatGPT, Gemini for reasoning, for planification, for understanding, and all the smaller models are running locally, like perception, localization, audio to text, text to speech. So we are leveraging the fact that everyone is working for us, as Firas said, is a gift. So big models are evolving quickly. At the moment, I think most of the robotic companies are trying to push their product into the market, especially because we need a lot of quality data, labeled data. And each robot is different, so each platform gives different data. And we will need to train new models with those data in the next few years. But yeah, I don't know about the cost of all that, but at least we need the data now.
So that does it mean that you fine-tune some type of models for your robots, or?
Well, I wouldn't say that we all, I mean, so the fact that you need to run models on board, they need to be small, as you just said, right? And small models, they have an advantage, is that they are cheap, right? So basically, if you think about, for example, a reinforcement learning model, which, let's say, is controlling the movement of the robot and the body control of the robot, these are models which you train sim to real. And basically, you just need a good GPU, and then you run the robot in simulation. You need, of course, a good engineer also. And then you have a model which is running on the robot, and it is quite cheap to produce compared to what we think about models when we think about VLMs or LLMs. So the idea with robotics, some people today in robotics, they are trying to have this one model which is fully end-to-end and which does everything and includes text. It's conditioned on text and images and so on, and it generates actions, joint-level actions at the end. And this is a very cool topic, and it might be the future, but it is still a research topic. Today, if you want a product in 2026 in the market, you have to, if you want, put some seat belts on your model right now. You cannot just put it there and have it run. And so the way to do that is actually to have layers. So you need a big model which might hallucinate, which kind of like get it right 80% of the time. And then you need at the lower level another model or other multiple models, basically, which are much more robust and which are trained, for example, with reinforcement learning, or basically trained, or even handcrafted sometimes, and which are robust. And the interface between these models today, if you want to really put a product, and in all products which are in the market, the interface is not a latent space. The interface is a controlled interface. It's a controlled layer. You know what? You control what's your output. You are able to test your model separately. You are able to validate your model separately. You are able to grow your model separately. Otherwise, you cannot afford to do better. Maybe in 5 years, I mean, not maybe. I am sure that in 5 years, when we have enough data, we will have a one model which does great on all of the stack, but it's not in 2026.
So does it mean that you are going to have like one model for each of the tasks that you're asking your robot, and then you do a global model that is using the different type of model? It's like a kind of mixture of experts, right? If I could say.
Yeah. You can think about it this way. So basically, you would have a big model which has access to functions, or you can think about it as MCP servers. It is kind of the word, or function calling with the VLMs, and then it's able to call these models, and these dedicated models are task specific, and they are very good at the task which they do, and they are small, and they run on board. So that's kind of the idea.
On your robot, do you have like a strong GPU, NPU, TPU? Does it not consume too much? How do you deal with?
Yes, so we were gifted as well by NVIDIA to release their Jetson ecosystem. So we have 2 GPUs on board on the robot. They are still like 25 watt, 30 watt GPUs, so nothing compared to H100 and stuff like that. But yes, the hardware part of the robotic is evolving very quickly. Joint level compute resources. NVIDIA is releasing new kind of hardware every year or every 2 years, and others are following. More and more we see that there is some small AI accelerators, hardware accelerators coming, and it's really something that we need as a robotic integrators to be able to run VLM, LLM locally on dedicated hardware that are not like full GPUs.
Do you have? So you're going to have a ton of models, right, in a robot, right? Does it mean that you also have, like, let's call it classical machine learning models, which are not Gen AI, I guess? Does it still exist? Or?
Yeah. I mean, all robots have CNNs running on board, for example, like today. All robots have CNNs, classic vision treatment, which is running on board, which is useful for basic stuff. Of course, you also have classic obstacle avoidance. Classic, you need it also for certification, right? Because certifying a robot is also very different than certifying an LLM or certifying a word model. So it's also a different game, and so you still need some classic machine learning and some classic methods to be in there.
Yeah, and speaking about that, like your robot is for normal humans, right? It's not a drone flying distance, right? It's going to be with your grandma and so on. Like, what are the you need to do a ton of things on social interaction, I guess, right? Is there, and when you see like Boston Dynamics robots, right? It doesn't seem that they're there to interact with humans. So what are the constraints? What are the new things you had to do for, or you're probably researching today on like talking with humans, right? And
yes, that's a very important point for us at GeneTools. As I said before, we are one of a kind robot. It's a very social robot, and think about it as a difference between function and emotion. Most of the robots right now are focusing on function, on capabilities, and we are lacking a lot of development into the emotion side, the HRI, the human-robot interaction, even if there's a lot of research about that. When you meet someone new, you start connecting with them by emotion. You're making them getting their way of speaking, etc. You are not evaluating someone based on how far they can jump or something like that. And it's the opposite for a machine. You buy a machine by looking at the specification and say, okay, it will do this task. And robot is right in the middle. You want it to be useful, so you want it to be able to do a lot of things, but it will be a part of your home, of your store. So you need to connect emotionally with it. So it's very important to have this social connection for robots to be able to have an adoption of the robot in the future. And we do it by many different ways. We do it first by design, with a cute robot, not scary robot that you can approach. We do it by software, by spending a lot of time trying to mimic human behaviors, to catching their emotion, their gaze, their way of speaking, the emotion. So it's not only about the robot showing emotion to the person, but also the robot getting the emotion from the person to get a good connection. So we can talk about this.
Does it mean that you have like cognitive researchers, socio political people who like really not the usual people you will see in any AI startup, right? Where you have AI engineers, data engineers. That means that you have like a psychologists and other type of different people that you don't see often in startups?
So we do actually, and we have on our scientific committee a couple of people who are specialized in psychology. And there is a robotics community around human-robot interaction. And this community is a mix of people who come from engineering or psychology, but who are sensible to these topics. And we do have these type of people with us who have been doing robotics for HRI for a while. And I mean, this ranges from simple stuff to more complex stuff. For example, if your robot is around children, they talk usually fast. They want the robot to be responsive, to be punchy, to be basically maybe a bit mean sometimes, I don't know. But then if you put the same robot in front of older people, they talk slow, they take gaps between their speech. You might think that they finished their sentence, but actually they did not. They want the robot to be much more empathetic. They want the robot to kind of much be emotional. And even like these differences, I think very few people in robotics are focusing on them. And I think that they are the right topics to focus on, because they are very important for acceptance. And it is really crucial for robots to be deployed and for people to want the robots to be deployed to take care of this stuff.
Okay, a very short question. What is a world model? I've asked these questions 25 times this morning, and like everyone has a different answer. Can you give us a short answer of what it is?
Yeah. First, it is used by different people for different purposes, of course, like any term of AI. The main difference between a word model and a classic model is that the word model respects physics. So a word model should respect physics.
So it's really engine for video games plus AI?
It is video games, but video games can be fantastic. Like you can have fantasy in video games. In a word model, you cannot have fantasy. In a word model, it's supposed to respect physics all the time. So it's supposed to be as close to reality as possible. If you think about a robot word model, so like very recently, in the past couple of months, there's a couple of papers about robot word models where the model defines the word the way the robot sees it. So to give a very, very short answer, when you do reinforcement learning, maybe it's already long, but I will try to keep it short. When you do reinforcement learning, you have the agent, which is interacting with the environment and getting rewards and then learning, right? This is kind of the basic paradigm of reinforcement learning. You can do this in the real world. You can do this in simulation. And the idea is that you will be able to do this in a word model. So that's kind of the idea of a word model. It is a perfect simulation of the word. It is a simulation which is photorealistic and which is as close as possible to reality, such that agents can train inside and improve. Because simulators are not photorealistic enough. You cannot do really sim to real with RGB right now. And the real world is very expensive.
And guess another question, which is, we talk a lot, and we've seen a lot of like videos of robots doing completely insane and crazy stuff. Do you have a lot of work on safety, right? Around, especially if you're focusing on healthcare and older people and so on. Like, how do you approach safety?
Yes, yeah, we are putting a lot of guardrails and seat belts around the models that can hallucinate, because an hallucination in the physical world is a direct action that is not reversible. So yes, we have classical algorithm that keep the parameter of what the output of a model could be, and limiting the action of the robot. The other way that we did it on our own robot is to limit the kind of action it can do. So prevent it from falling, preventing from taking any object. The MirrorKai can only take objects that are with special handles that is made for it. So it will. So we protect the environment from the robot like this. And another way of doing it, some other company does it with teleoperation. They are putting robots into homes, into stores, and there is a human connected to the robot that will handle all the action, and we just use this physical body inside remotely to train.
And yeah, you use the teleoperation to train new models and gather more data, I guess.
Yes, there's a lot of stuff about physical data being collected by teleoperation of robots, or even, like they said this morning, with glasses or special hardware that you put on humans doing tasks and just recording them.
Thank you so much. I think we could, it's an amazing topic, probably the best topic. We could stay 2 hours, but we need to go. Thank you very much, Firas. Thank you very much, Grégoire.
Thank you.
And thank everyone.
Thank you, everybody.